Hello students, welcome to Satya classes. Myself Raj and I am here with a new topic, trigonometric ratios of some specific angle. This is the part 4 of the trigonometric series. So to understand what are some specific angle, let me tell you one thing. We choose those angles for which we can obtain the relation between the sides of the triangle very easily. Understood? These are some specific angle, so that this reduces the using of maths in very complicated manner. Soon you will feel this. So I would like to suggest you to watch the video up to the end, and I am really very much sure about this that you will learn in this video a little concept and very useful concepts. So let's begin. To study trigonometric ratios of some specific angle, there are some need that you must be knowing for the study of trigonometric ratios of some specific angle. The first requirement is you should be knowing about how to write trigonometric ratios for right angle triangle. This is the basic requirement, and the idea of doing so I have told in my previous lectures. So please go there. If you had not watched yet, then go there and learn from there how to write these things. And the secondary thing is the use of Pythagoras theorem. So let me explain it once more. When you are going to calculate hypotenuse of a right angle triangle, so hypotenuse is equal to root of base square plus height square. In this case, a square plus b square. You can see clearly this is a and this is b. So in under root a square plus b square. Now are you clear with it? So let us revise what we have learnt in previous, so that this makes our problem easier, reduces the effort. So let us revise. Our revision will be in the form of a question. So let's see the question. You can see over here I take two questions, 1 and 2. So the first question has a triangle having side 4, 5 and 3, and for the second triangle the side length are the same, but the difference is only that I am taking theta on the base 3, and in the question number second I am taking phi on the base 4. Understood? And we are going to calculate the value of sine theta for case first and sine phi for case second. So let us see. Sine theta is equal to perpendicular upon hypotenuse. Now you are able to write these things. Okay, perpendicular upon hypotenuse. So perpendicular means if this is theta angle I am taking for, and then what will be the perpendicular? Yes, of course, 4 meter will be the perpendicular. So 4 meter. And what about hypotenuse? 5 meter. 4 meter upon 5 meter gives you 4 upon 5. Understand? And for the second case, if I am taking phi here, then perpendicular will be this side. Understanding? Perpendicular will be this side, and 4 meter will be the base. So 3 meter by 5 meter gives 3 by 5. Are you clear? So see, when I take theta, the value is 4 by 5. When I take here phi, the value is 3 by 5. Means changing the angle changes the ratios. Understand? So from this question, I made you clear that changing the angle changes the ratios. Now understand? Okay. So move to the some specific angle like 0 degree and 90 degree. So again we are taking two angles, 0 degree and 90 degree simultaneously, and you will soon understand the reason behind this. So for this, first of all, we have drawn a right angle triangle. You can see over here ACB is the right angle triangle, and AC is extended up to Q and AB is extended up to P. This is I did here just to make the diagram much clear to you. So for making 0 degree, since this is some angle theta, some general angle theta, and when you are about to make this theta angle up to 0 degree, what you will do? So let me tell you what you will do here. First of all, the need of doing is, this is the hypotenuse, you know about it, and hypotenuse is giving rise an angle theta. When you bring this hypotenuse to the base, when you bring this hypotenuse to the base at point B, your angle reduces. You can see over here, look at the A vertices, the angle is reducing, your angle reduces, and this becomes 0 degree when the line segment completely overlapped on AB. So for this we can say that the hypotenuse becomes equal to the base. Hypotenuse is become to the equal to the base for this angle. Understanding? Are you clear with it? Let me do it once more. This is that length which is inclined at angle theta, and this angle is theta. This angle, you can see the orange color, this angle is theta. So I wanna make this theta equal to 0. So for making it 0, we will bring down this hypotenuse and completely it will overlap on B. Now you can see that orange color is occupying no angle, means the angle becomes 0. So for this purpose the hypotenuse will be equal to the base length. Now are you clear? Okay, AC is equal to AB, and the BC length becomes 0 because there will be no BC. When you bring AC down to AB, the BC length becomes 0, so BC will be 0. For this, sin A, so I told you how to write the ratios. Sin A is equal to what? You can see over here, perpendicular upon hypotenuse. So perpendicular is what? This length, and this length is equal to 0. So sin A will be equal to 0. Understand? Okay, now what about cos A? Cos A is equal to base upon hypotenuse. And what is the base? Base is AB, and hypotenuse is equal to the base. So this gives rise to one. Cos, instead of writing A, we should write it as 0 degree, and sin 0 degree will be 0, and cos 0 degree, cos 0 degree will be equal to how much? 1. And now what about tan? You know tan, how to write ratio of tan? Do you know? Yes, of course. From here you can see perpendicular upon base. So what is the value of perpendicular? Perpendicular length is 0. So tan 0 will be equal to what? 0. This will be equal to 0. Now you have calculated the three ratios: sin 0, cos 0 and tan 0. Sin 0 is 0, cos 0 is 1, and tan 0 is again 0. Now I am giving you a homework problem, but before that let me hint about the homework problem. So I want to give you to calculate all the ratios about 90 degree angle, but for doing so let me make you clear about how to make 90 degree angle when you're trying to make this angle, this orange color angle. So for this purpose you have to do, you will bring the point A to point B, and the angle becomes 90 degree. Okay, let me make it clear. Keep looking at the pointer. Now this is the length AC, which represents the hypotenuse, and when you bring this AC length to B, For this you can clearly see that the length of AB is getting reduced. The length of AB is getting reduced. Okay, let me do it. Okay, this angle, suppose this length, keep looking at the length. Now A point is shifted at this point. A is here. Again I am doing. After some time, as the angle, now A is here. So when this point comes to B point and overlapped on this point, this becomes 90 degree. Understand? Now the theta angle becomes equal to 90 degree, and for this the length of AB is equal to 0. So let me write here, the length of AB is equal to 0. AB will be equal to 0. And what about others? The hypotenuse will be equal to the perpendicular. The hypotenuse will be equal to the perpendicular, means the secondary thing is AC is equal to AB. Understood? Now you have these ratios, you have these sides, and now you are able to calculate ratios. So homework is calculate the trigonometric ratios of 90 degree angle. Understood? My aim is to calculate trigonometric ratios of angle 30 degree and 60 degree. We are taking both the angle simultaneously. This is only because the procedure of doing for calculating the ratios of 30 degree and for 60 degree are almost same. So we are taking both the angles simultaneously. Understood? So for doing so, first of all, let us draw an equilateral triangle ABC, and its sides are of length 2a. Understand? We are taking 2a just to make it simple as much as possible. So you know about it, each vertices have angle of 60 degree. Understand? First of all, let us draw a median from A to the side BC, and it becomes P point. So this is at 90 degree because of symmetricity of this equilateral triangle, and this angle will be equal to 30 degree because previously it was 60 degree, complete angle was 60 degree, and on dividing it becomes 30 degree. This is the property of equilateral triangle, nothing to worry about. Now the side will also divide itself, and this was complete 2a, and this is what? This is the median, so it will divide this length equal to a, and this will be also a. So now you can see clearly ABP is a right angle triangle, isn't so? Yes, it is. So let me write it down. Triangle ABP is right angle triangle. Now what next? As ABP becomes right angle triangle, now we are able to apply the ratios. Which ratios? Trigonometric ratios. Understand? But before, let us calculate the length of AP so that we can have the base length when we take 30 degree angle. So for this, let us apply Pythagoras theorem. This is so simple. You have done earlier. AP will be equal to, this side length is 2a, so 2a square minus, you can do this work in your copy along with me, 2a square minus how much? A. 2a square minus a square. This gives root 3a square. 2a square becomes 4a, 4a minus a square becomes 3a square. This equal to root 3a. Understand? Now you have the length of AP. So from this triangle ABP, let us write sine 30 degree, which is equal to, look here, Pandit Badri Prasad Har Bole. So this gives for the sine perpendicular upon hypotenuse. Understand? The value of perpendicular you can see over here. For 30 degree angle, perpendicular will be BP. Perpendicular will be BP upon hypotenuse. Hypotenuse will be AB. AB. So BP upon AB. You have calculated BP. BP is equal to A. So it will be as A, and AP is equal to 2A. AB is equal to 2A. So becomes 1 by 2. A will cancel each other and it becomes 1 by 2. Understand? I don't think there is any problem in this. So move to next. Next ratio is sine then cos 30 degree. For calculating cos, again look over here, base upon hypotenuse. Now the value of base for this 30 degree, base is A to P. So AP, and then hypotenuse remains same, AB. Then AP upon AB, the value of AP you calculated here, root 3A. Understand? Root 3A. And thereafter AB, length of AB is equal to 2A. So this gives root 3 by 2. Understand? Move to next, tan 30. Now you can tell me, tan 30 will be equal to what? Perpendicular upon base. So let us see. Perpendicular is what? For this angle, what is perpendicular? BP. Exactly. BP. Perpendicular upon base. So the value of base will be AP. So AP. This is equal to BP is equal to A, and AP is equal to how much? You have calculated here. Look, this is the value of AP. Then put it, root 3A. This gives 1 upon root 3. Now you have calculated the 3 ratios, and the remaining other 3 ratios are reciprocal of these, so they can be easily calculated. Understand? Now we are done with the trigonometric ratios of 30 degree angle. So let us proceed for 60 degree. Since you can see here clearly that 60 is on vertices B, so which will be perpendicular and which will be base? Do you know about it? I told you. Let me tell you again. AB is the hypotenuse, AP will be the perpendicular, and BP will be the base for this 60 degree angle. And we are using triangle ABP, which is right angle triangle, as we used for 30 degree. Understand? So let us proceed. First of all, sine 60 degree, which is equal to, see here, perpendicular upon hypotenuse, and perpendicular is AP upon hypotenuse. Hypotenuse is AP. So AP upon AP. AP length is root 3A upon AB is equal to 2A. This becomes root 3 by 2. So sine 60 degree is equal to root 3 by 2. Move to next, cos 60 degree. Cos 60 degree is base upon hypotenuse. So base you can see over here, BP is the base, BP upon hypotenuse, AB is the hypotenuse. So BP is equal to A and AB is equal to how much? 2A. Yes, so it becomes 1 by 2, means cos 60 degree is equal to 1 by 2. Now one more ratio, tan 60, which is to perpendicular upon base. Now the perpendicular is AP. So AP is the perpendicular and base is BP. BP is the base. So let me write it as AP is equal to root 3A upon BP is equal to A. A cancel and it becomes root. Now the three remaining are reciprocal of these. So let me write it quickly. For cosec A means 60 degree is equal to 1 upon sine 60. And you know about sine 60, root 3 by 2. So it becomes 2 by root 3. And remaining are the homework for you. Sec 60 degree and tan 60 degree. Tan have calculated. Cot 60 degree. Cot 30 degree. These are the homework I am writing here. Sec 30 degree and one more cosec 30 degree. These angle you will try to calculate in your note copy and post your answer in comment section. Now I am going to calculate trigonometric ratios of 45 degree. So for 45 degree we must have a triangle which is right angle triangle. So let us draw right angle triangle. This one is the right angle triangle and right angle is at B. A, B and C. This is right angle triangle. Now the challenge is we have to make an angle which is equal to 45 degree. So let us make it 45 degree. As we make it 45 degree and this is 90 degree. So according to the sum of interior angle of triangle, you can see here angle A plus B plus angle C is equal to 180 degree. Understand? Now put the value of B and C, angle B and angle C. What you will get? Angle B is 90 degree and angle C is 90 degree, angle C is 45 degree and angle A. So if you solve this, angle A will becomes also 45 degree. So now this is also 45 degree. Means what? This is a triangle which is isosceles right angle triangle. Understood? This is isosceles right angle triangle, and as this angle becomes equal to this angle, this side will be also equal to this side. So suppose the side length of these two sides as A and A. So what about this? Let us apply Pythagoras theorem for this side. AC is equal to under root A square plus A square. A square plus A square, how much? Yes, 2A square, and this becomes root 2A. Understand? So from here we can see we can take any angle, either this angle or this, because both are equal to 45 degree and there will not be any change in trigonometric ratios. So I am taking this angle as a reference. So this will be base and this will be perpendicular. Understood? Sine 45 is equal to, okay, say Pandit Badri Prasad Har Bole. I am writing it again and again so that you are familiar with this funda and there will be no time issue to write it. Understand? So again, see, perpendicular upon hypotenuse. The perpendicular is A and hypotenuse is again A, but we will write it as AB upon BC. Okay, so AB upon BC is equal to how much? AB upon BC. Sorry, this is not BC. Starting again, sine 45 degree is equal to perpendicular upon hypotenuse. So perpendicular is AB and hypotenuse is AC. A to C. Okay, hypotenuse is AC is equal to the AB is A and AC is root 2a. So this gives 1 upon root 2. Understand? Move to next. Sine, then cos 45 degree. Cos 45 degree is equal to base upon hypotenuse. Base is BC and hypotenuse is again AC. So this gives A upon root 2a is equal to 1 upon root 2. Means for 45 degree, cos 45 and sin 45 both are same, both are equal. Let us move to tan 45 degree. Tan 45 degree. So for tan 45 you will perpendicular upon base. So perpendicular is AB upon base is BC. So this equals to A upon A is equal to 1, and the remaining other are reciprocal of these three, and soon I will give you the table, and you can see the table is of every ratio having angle 45 degree, 60 degree, 30 degree, 0 degree and 90 degree. So in the next slide you will see the table. You have seen how I have calculated the following ratios of sin A, cos A and tan A on angle 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Now we obtain the following table by the calculation. Understand? But here you can see clearly that cot A is not defined for angle 0 degree, sec A is not defined for angle 90 degree, cosec A is not defined for angle 0 degree, tan A is not defined for angle 90 degree. Now what are not defined values? So for this value, when you divide some number by 0, then the answer what answer comes, it is not known by anyone. So that answer is written as not defined. Understand? This is the basic funda about not defined. So now we shall stop here and see you in the next presentation with some interesting question based on trigonometric ratios of some angle, with some tricks and some important question regarding to your board examination.